Hi, Rock Creek scientists. Now we're talking about how much force does it take to disconnect two magnets. So if we pull on those two magnets, eventually it loses the force that's holding them together. So we're going to figure out how many newtons does it take to break the force between two magnets. And we have our setup with our spring scale, our magnet on the outside and the magnet in the cups there. We're going to pull. And the spring scale is going to record how many newtons it took to break the connection, and it was 0.6 newtons. 0.6 newtons to break the connection. What do you think will happen to the force of attraction between magnets if you put some distance between the magnets? Do you think the force will get stronger, weaker, or stay the same? Record your prediction. So do you think it's going to get the force will get stronger, weaker, or stay the same if we put distance between the magnets? So what we're going to do is, in our two cups there, we had that one magnet. So now we're going to place two spacers, then the magnet, and then the other cup holds it in place. So now you have the magnet, two spacers, and then magnet again. So will the force needed to break that connection be stronger or weaker? And it was only 0.1. So the farther away the magnets are, the easier it is to break the connection. So the more space in between, the less force it takes to break them up. And here's an example of a student data. So with 0 spacers in his trials, it was about 0.83 average to break them. When he had 1 spacers, it was 0.6, 0.75, 0.7, so an average of 0.68. 2 was pretty close to the 1. And then 3, it drops down to 0.5 newtons. So as you can see, with the more space in between the magnets, less force is needed to break the magnet's connection.